take a bit of time to look at travel graphs, which of course you saw way back in junior school, but they were very simple things, travel graphs, and they're usually just straight lines and things like that. But there's no reason why a travel graph has to have straight lines. See, if we were to get a ball and bounce it and just graph its distance from the ground, it actually would turn out to be a parabola when we graphed it. So we don't always get straight lines. The equation of this particular ball being bounced is 5t outside of h minus t. That's the equation of the curve. Now, the sorts of questions we were asked for travel graphs is the total distance. Now, distance, of course, is the total amount travelled. We're now going to introduce another term called displacement, which is different to distance. Displacement is how far from, well, some reference point, usually the starting point, but they're asking distance. So for our little ball here, if I was to calculate the height of the ball after 1 second, well, I could just plug it into our formula, and there we go. We know it's at the point 35, or it's 35 metres up. At what other time is the ball the same height? Well, I could solve the equation, see when we've got the equation of the curve. Depends how accurate the graph is. I suppose we could read off the graph. And we end up with t equals 1, which was the one we knew about already. And again after 7 seconds. Now, the average velocity would be the change in displacement over the change in time. Right? So x2 minus x1 over t2 minus t1. That's different to the average speed. Speed would be the change in distance. Let's have a look. The average velocity during the first second. Well, I know that after 1 second it was at 35 and it started at 0. So what do you know? It travelled 35 in 1 second. So 35 metres per second. The average velocity during the 5th second. So it's not saying after 5 seconds, it says during the 5th second. So when it went from t equals 4 to t equals 5. So t equals 4, it was 80 metres above the ground. T equals 5, it was 75 metres. So the average velocity, you'll notice we get a negative number. That's also the difference between speed and velocity. With velocity we can have negatives, but the negatives mean something different because we're talking about a rate of change. And as we've seen with our rate of change, negative means decreasing when we're talking about some things. With velocity and displacement, these sort of questions, basically it's telling us something about the direction. So negative 5 tells me, yes, it's travelling at 5 metres per second, but it's going down. It's travelling in the negative direction. So average velocity, negative 5 metres per second. Find the average velocity over its whole 8 seconds in the air. This is where it becomes a little bit strange. Well, average velocity. It started at 0, it ended at 0, so the average velocity, 0. Now, some people when they first see this think, well, hang on a second, how can it be 0? We know the thing moved, it must have an average velocity. But the point is, for some of the time it was going up, and for some of the time it was going down. If you look at what has happened over the 8 seconds, I'm at 0, and I ended up at 0, so really I haven't moved at all. And that's why the average velocity is 8 seconds. And again, that comes into the difference between distance and displacement. My total displacement is 0. I haven't done anything. I'm still at the same spot. Yes, the distance I travelled was however many metres up, and plus how many metres down. So average speed, which would be the distance travelled rather than the displacement, now that's going to have a value. Because the distance travelled, 80 up, 80 down, so all up I've travelled 160 metres in 8 seconds. So my average speed was 20 metres per second. But my average velocity is 0. That's just a quick little talk about, well, travel graphs.